applications of trigonometry. Here, in the applications of trigonometry, usually we used to find out height and distance. In the previous example, we have clearly discussed about how heights and distances can be calculated by using trigonometry. Now, today, let us solve some problems from exercise 9.1 from class 10 textbook. Problem number 6. Let's read this question now. I'll read the question for you. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation means what? Straight eyesight. The straight eyesight up is called angle of elevation. Always angle must be measured from the straight eyesight. Now the question is, the angle of elevation from his eye to the top of building increases from 30 degrees to 60 degrees as he walks towards the building. Find the distance he walked towards the building. A 1.5 meter tall boy is standing at some distance from 30 meters tall building. The angle of elevation from his eye to the top of the building increases from 30 degrees to 60 degrees as he walks towards the building. Find the distance he walked towards the building. Dear students, how to understand this? Let me draw one rough sketch for you. Suppose this is the level ground. First, where you need to understand, there is a boy. Here, look at this. There is a boy and building. Look at here. This is the building. There is a boy and building. First, somewhere, according to as per our idea, we'll draw building and so this is building. Somewhere just I'll draw just rough sketch. You can just see, check it out. Somewhere this is the building. This is the building, and somewhere here is this is the boy, boy of somewhere they are standing each other. So here this is the boy. So this is the boy and 1.5 meters tall, and this is the building. First, check it whether he has given height of the building. Look at here, 30 meters tall building. So that is, this is 30 meters already he has given. 30 meters he has already given this building height. Dear students, once again now I'll draw this diagram systematically. So here, look at this diagram. What we have to find out? First, read the question carefully. First, what we understand is, first somewhere this is the boy Here it is the boy and building. First, somewhere we draw boy and building. As per our guessing, first we draw this building and this. Look at it. So first, let me, already I've drawn the diagram for you systematically. Just once again, this is the level ground. This is the level ground. And here, this is the building. This is the building. This line is the building. And suppose this is, I'm going to name it as CD is the building. And 30 here, look at this, 30-meter tall building. That is, this height is already as given 30 meters tall. And somewhere the boy, 1.5 meters, somewhere we can draw the boy is of 1.5 meters long. A boy here, somewhere on the ground he is standing. Here it is the boy. Here is the boy. So you name it as A, B is the boy, and it is 1.5 meters. But first, before solving such questions, distance between boy and building, whether they are given or not, that you have to identify. We'll see. A 1.5 meters tall boy is standing at some distance. Listen here. At some distance from building. Some distance, we don't know that distance. That he has not given. Assume that this distance is totally, that this distance is X meters. Look at this. This is the distance total. The distance between boy and the building. Some distance. That is, suppose, assume that this is X. So X meters. We don't know that is. Once again, read the question now. It takes its time to read this question now. So here, the question is like this. Boy, look at here, standing at some distance from building. From building, boy, some distance. That distance we don't know. Assume that distance is the distance we have taken it as X meters. X meters is the distance between the boy and the building. The angle of elevation. So here, first from the eye to the, from eye. So first we make one eye here. It is, look at this. Here it is the person, that is the eyesight. First, this is the eye. First you make eyesight is straight. The straight eyesight. First, wherever, next, later on we'll see that. This is the straight eyesight. This is called straight eyesight. First, we'll make it a straight eyesight here. Straight eyesight. Straight eyesight. Straight eyesight. Then, all of you see, this is 1.5 means here automatically this is 1.5 meters. Total is 30. That means this will become 28.5. That is correct. This one you can name it as, suppose we'll name it as, this is the point is G. We can name it as, this is the point is G. This point is name it as now G. This is the point is, we name it as G. Now what he has seen that. Now read the question now. This is very much important, my dear children. First, you need to understand the question properly. First, you need to understand the question properly. Look at it. The angle of elevation from eye, that means always angle should be measured from straight eyesight to the top of the building. That means he has seen the top of the building. He has seen this. He has seen the top of the building. He has seen the top of the building. First angle is, he has given here 30 degrees. First, he has seen this angle is 30 degrees. Elevation, this is 30 degrees. Top of the building increases from 30 to 60 as he walks towards the building. Now he starts walking towards the building. Suppose, see, this is, yes, he has just walked up to this here. That is the EF. This is the new position, the boy position, that is EF. EF is the position. He walks from here, it is the first position. He walks, look at him, he walks towards the building. That only we have to, how much he walked. Assume that he has walked distance of y. Assume that this distance is how much y. We don't know, that is the one. That is the question. Find, the question is, see that. Find the distance he walked towards the building. Towards the building, how much, that is why we have to find out here in this question now. We have to find out. So after walking some distance, from there again he has seen the top of the building. Again from there he has seen this. That time the angle of elevation is 60 degrees. So like this. Now I'll read the question clearly for you once again. Read the question now once again. Look at it. A 1.5 meter tall boy is standing at some distance from 30 meters tall building. The angle of elevation from his eye to the top, he has seen the top of the building, increases from 30 to 60 degrees. That means first it is 30. First it is 30. Afterwards, it is increased to 60 after walking towards the building. So assume that how much he has distance walked. Assume that the distance walked by him towards the building is, say, y. That is the question he has asked us to find out here. You see that. Find the distance he walked towards the distance. That is how much we have taken. The distance is walked by him towards the building is y. So we have to find out y. That time, the angle of elevation is from 30 to 60, it is increased. The angle of elevation is 30 to 60 degrees. So this is 1.5. That means in the diagram, CG is equal to 1.5 and DZ is equal to 28.5. Why? The total distance is 30. The total distance is 30. So this is the question where we need to prove that. Now we have to find out. Then what is this distance now? Can anybody tell me now? This is C. Total is X, means definitely this will become X minus Y. This will become X minus Y now. Because after adding, you must get X, no? After adding this to X minus Y plus Y, Y gets cancelled. Therefore, you get X only. So what is the final question here? You read this question now. What is the question we need to find out here? Look at here. We have to find out, look at here. Find the distance he walked towards the building. Find the distance he walked towards the building. So how much distance he has walked? We have taken it as Y. And this remaining will be X minus Y. Why? Because total distance we have taken as X. So we have to ultimately, we have to find out the value of Y. The distance walked by him towards the building is Y. Now the systematic diagram I've written here, my dear children, I hope so you can understand this clearly. Look at it. Here I'll explain systematically. Say AB is the boy. AB is the boy, 1.5 meter tall. And assume that he has walked towards the building. How much distance he has walked? Assume that this Y units, Y meters he has moved. Y meters. The total distance you have taken as X. And definitely the remaining is X minus Y. So ultimately our question, we have to find out Y value. That was the question now. So directly we'll start writing. So I've written here systematically, AB is the man and AB is equal to 1.5 meters given. CD is the building and CD is equal to 30 meters. AB and EF are the positions of an observer. First, here you can see that here AB is the first position of a person. After walking towards the building, EF is the second position. That's what I've written clearly. AB and EF are the positions of an observer. But how much he walked towards the building, we don't know. Assume that we have taken that. Let Y be the distance between AB. So, and the remaining is we take. So let we take this one. Let take AE in the diagram. AE or BF is equal to Y. Is equal to Y. Therefore, automatically, and we have taken this is one. Sorry, this is first we take this is the total distance. Let's take Let take the total distance is x here. The total distance between boy and the building is x. Let BC is equal to x. And we take that is AE in the diagram, or AE or BF is equal to y meters. BF is equal to y meters. Therefore, what is FC or CF? The CF will become x minus y. Why? The CF will become x minus y because after adding both, it should be x. Minus y plus y get cancelled, therefore x is equal to. And since AG, and that is equal to here in the diagram, A, E, G is the straight eyesight of a boy. Straight eye sight of a boy. Sight of a boy. Therefore, from figure, all of you, all the terms you write here, from figure AB is equal to EF is equal to CG, all are equal to 1.5 meters. Total building height is given. Total building height is given that 25. Then, so total is, see, this is total is 30 means 1.5 means that is DG. Therefore, from figure DG is equal to, from figure DG is equal to 28.5 meters. So a boy from here, a boy walks towards the building. How much distance he has walked? Assume that he has walked, the distance is y. That is our question. Once again, try to understand. Here, the final question is find the distance he walks towards the building he has asked. That is the question now. Already rough diagram I've clearly given. So now we have to solve this problem. Now we have to concentrate. Angle of elevations are already I've given. Angle of elevation, see, once again, read the question now carefully. Read the question now. So in the question now, the angle of elevation, in the question first, the angle of elevation from his eye, top of the building, that means he has seen top of the building from his eye, increases from 30 degrees to 60 degrees as he walks towards the building. That means first time he has seen 30 degrees. Afterwards, he started walking towards the building. Somewhere he has stopped after walking some distance towards the building. Again, he has seen the top of the building. That time the angle has been increased from 30 degrees to 60 degrees. So first he was here. The boy is 1.5 here. That time the angle of elevation is 30. From there he has started walking. Somewhere he has stopped here. Somewhere again he has seen this. That time the angle of elevation is increased to 60 degrees. So he has asked that to find the distance he walks towards the building. Here the building is here. This is the building. So what is the distance is? Assume that we have taken that he has walked y. The total distance we have taken it as x. Therefore, this will become x minus y. Why? The reason is after adding these two, you should get again x only. So angles of elevations are already given. So why we have to find out now? Angles of elevations are shown in the figure. Angles of elevations are angles of elevations. Angles of elevations are shown in the figure. Dear students, remember in the diagram, all of you, I hope so you can understand. Here, this distance is x minus y. Then automatically this distance is also x minus y. This distance is also x minus y. Correct? These distances. Now, first I'm going to shade this triangle, the shaded triangle. I'll take this triangle. I'll apply tan 60. So number one, I'll tell you, in this shaded triangle, if I apply sin 60, opposite by hypotenuse, here our task is only this distance you have to find out, this distance. That means nowhere hypotenuse is not included. Hypotenuse, nowhere it is essential. Therefore, we stop using sine and cos. Only tan. First, I shaded this triangle. I'll take triangle DEZ. This distance is 2.5 already. We know that this distance is. Ultimately, our target is, once again, I'm writing, ultimately, the distance he has traveled, that towards the building is y meters we have taken. This distance only has asked us to calculate. That is why we have to find out y now. So first consider this right angle triangle. From the right angle triangle DEZ, from the right angled triangle, from the right angled triangle, I think, what is this right angle triangle? Once again, observe this. DEZ. DEZ. From the right angle triangle. So DEZ. Once again, I'll write here only before that. What is tan 60? Tan of this angle. So here I'll write first tan 60 definition. Tan, this right angle triangle, no, we have taken. Opposite by hypotenuse. 28 point divided by hypotenuse will become now x minus y. So definition is opposite by, opposite is 28.5. Tan 60 is equal to, tan 60 degrees is equal to, opposite is 28.5 divided by adjacent side x minus y. Cross multiply it now. We are again and again, every time the target is y. So cross multiply it now. X minus y is equal to 28.5 upon tan 60. Listen carefully. And we want y. So therefore, y you take, you shift it to right hand side, and 28.5 by tan 60, you shift it that side. That is y is equal to, this will become y we want, y is equal to x minus 28.5 upon tan 60 value root 3. 28 tan 60 value is root 3. Call it as 1. Now, so dear students, now I'll write here only once again, so that already I've studied here. So here what happened, this right angle triangle already we have used. So what I'll do here, this angle and all, you forget it now. Everything you forget it, this. So now we consider this complete big triangle. I will show you. So this triangle, complete triangle I'll take now. This complete right angle triangle. So this complete right angle triangle. So in this complete right angle triangle, first here only I will write. Afterwards, I will just, so that it will be helpful for you. So here again, the distance walked by a boy towards the building we have to find out. Yes, students, you can see, of course, here already I've written. First, I'll complete here only, so that I'll rewrite once again this part. Rewrite this. Total building is 30 meters is given. Now, look here. In this right angle triangle, the total base is how much? X. In this right angle triangle, y we want already. So here already just we know that here the total distance is x. Total distance is from here to here, BC. So from this right angle triangle, we'll take, so from right angle triangle, I'll apply it there only afterwards. Triangle DAG, I'll apply tan 30 definition. Tan 30 opposite, what is opposite? 28.5 divided by total base. Total, this is total distance already we have taken here x. Cross multiply it now. We don't want, we want only y. Every time you question yourself that we need y. So cross multiply it now. That is x, you bring it up. 28.5 upon tan 30. And x is equal to tan 30 value 28.5 divided by tan 30 is equal to 1 by root 3. So therefore x is equal to, so x is equal to 28.5. So x is equal to, here you see that this is once again, x is equal to, here x is equal to 28.5 into root 3 meters. But we don't want x, we want this y, we want this is the portion we want. The distance walked by a boy towards the building, how much he has walked first? Y meters we have taken. So now this entire part, I will shift it here. We want this is x is equal to 28.28 by root 3 meters. This we can take it as 2. This is 2. Look, again, the diagram is of no use for you now. So now look at here. I will just take this one. I will write here. Now, once again, you see that here, once again, we want, look at it. Yeah, this is the part already we have written now. So now how to find out y? Taking 1, or put x is equal to, put x value how much? Put x is equal to 28.5 into root 3 in equation 1. This x value already we know that 28 into root 3 in x. Therefore, equation 1, y is equal to x value how much? 28.5 into root 3 minus 28.5 upon root 3. We want only y. Now simplify that, you are going to get. So in this 28.5, you take common factor. Y is equal to, by taking 28.5 common factor, it will become root 3 minus 1 by root 3. Take LCM, root 3 into root 3. 3 minus 1, that is equal to y is equal to 28.5 into root 3. 3 minus 1, 2 by root 3. So y is equal to, so 28.5, y is equal to 28.5 into 2. 28 2s are 56, that is 57. 57 by root 3. But again, further we simplify, 19 3s are, and further we simplify 19 into 3. Purposely we can write root 3 into root 3. Root 3 into root 3 is 3 divided by root 3. Then root 3 get cancelled. The ultimate 19 root 3 meters. What is y? So y is equal to, therefore, the final result is y is equal to 19 root 3 meters. That is the distance moved, or a boy walked 19 root 3 meters towards the building. That is in the diagram. This is 19. This is, once again, I'll show you now. Towards the building, how much distance? So here, look at here. This is the distance he has moved towards this. Look at it. So here, how much distance is, this is the distance moved by him. I hope it is, this is 1. So this distance is 19 root 3 distance, 19 root 3 meters. He has moved, he has walked towards the building. The ultimately go up and see the question now. You'll come to know. The question is what he has asked is, and the last part you can see that. In the last line you can read this. So here the question he has asked, look at here, here the symbol, find the distance, find the distance find the distance he walked towards the building. He walked towards the building. So how much distance he has walked towards the building? So the distance walked towards the building is, find the distance he walked towards the building is 19√3 meters. 19√3 meters. Thank you, my dear students. Really interesting problem. So we'll solve some more examples, such some different examples. Really, applications of trigonometry needs some good understanding the concept first. So usually, wherever hypotenuse is involved, you apply sine or cos. If hypotenuse is not involved, then definitely go for only tan. So thank you, my dear students. In the next coming class, we'll discuss some more difficult examples from your textbook. Hope you keep these videos properly and revise them whenever you require. Thank you.